In the last screencast, we talked about the 6 memorized trig functions. You still can't forget about those, but sometimes trig occurs in other types of problems. Those other types of problems generally occur within a quantities. So trig is inside some parentheses being raised to a power. Let's start with just a regular chain rule problem from derivatives first, just so you can see where this is coming from. So way back again in chapter 2, when we talked about trig, we had problems that look like this. Take the derivative of the sine squared of 3x. The very first thing we did was go ahead and convert it into a notation that was more practical. So instead of using this little 2 next to the trig function, we wrote it out with parentheses being raised to a power. It means exactly the same thing, but again, just like before, it's much more practical to put it with parentheses being squared. Then you can take the derivative using the power rule. The 2 comes down in front. We subtract 1 from the exponent, and then multiply by the derivative of the inside. Here, the derivative of the inside is cosine of 3x times 3. That's the part that most students forget about, this times 3. So keep that in mind. My final answer down here at the bottom actually just multiplies the 2 and the 3 together to give a more simplified version of the result. All of the work that you're going to see in this screencast is just taking answers like this and going in reverse all the way back up to that original problem. All right, so let's take a look at some examples. The first problem we're going to try together is example 13. This is off that same paper we worked with the last screencast. So the integral of sine squared of x times cosine of x dx. Now, just like regular derivatives, we're going to start by rewriting this problem in a more practical notation. I'm going to write the sine squared of x as a quantity being squared. Here's what it looks like. The first question you want to ask yourself is this a memorized function? Is this one of the 6 trig functions that we now have committed to memory? The answer is no, just because we don't have any of the functions that say sine x squared times cosine x. We have cosine, we have regular sine, but not this exact combination. So this is going to be a power rule, where u is equal to the sine of x, and its derivative is cosine of x. You can see in the problem how we actually have a cosine of x off to the side here. So I'm going to go ahead and block that off as du and get rid of it. No modifications need to be made. Since we decided this was a power rule problem, I don't want to use the 6 memorized trig functions. Instead, I'm just going to go ahead and do the power rule. Add 1 to the exponent and divide. And there's the answer. One thing I want you to notice is that whenever we did u and du, even though this is an integration problem, we're actually doing the derivative now. So not only do you have to have your integral trig functions memorized, but also your trig derivative functions. That's why I said that the cosine was positive here. Let's look at another one. Number 14, we have cosine squared of 2x times sine of 2x. Once again, make that conscious decision to think about, is it memorized or not? We don't have cosine squared memorized, especially something with sine attached to it. So I'll start the problem by writing it in a more practical way. All right, so now we have u is equal to the cosine of 2x and du represents its derivative. Cosine's derivative is negative sine. Times 2. We don't have that in the problem, so we're going to have to make an adjustment. I need a negative 2 at the back and a negative 1/2 in front. As soon as that's done, everything is worked out for a power rule. We have a u, a perfect du, so I can add 1 to the exponent and divide. That negative 1/2 stays in front, and I'll have cosine of 2x cubed all over 3. You can simplify it if you like. This is your own personal preference, but I like to put those fractions together. In front is negative 1/6 cosine of 2x cubed plus c. All right, let's look at one last example. Tangent cubed of 5x times secant squared of 5x. This is number 38. In all the other problems, it was pretty obvious which one was going to be the u value. It was the one with the trig function. So for this one, we're going to have to actually think about it. There's two different trig functions with a power, the tangent and the secant. So basically, you just kind of play around with it to see if you can get the u and the du to work out. In general, we use the higher power trig function as the u value. Not always, but most of the time. So that's where I'm going to start. I'm going to assume that the tangent is the one we're going to be working with. So here's how I'll rewrite it. So this assumes that tangent of 5x is the u. Tangent's memorized derivative is secant squared. So when we work with trig, we're going to have to make that conscious decision about what type of problem we're working with. Is it a memorized function, one of those 6, or is it just a trig function that's merely inside a quantity? It's got to be one of those two things. Can't be both. So in other words, you're never going to change a trig function and do a power rule at the same time, one or the other. Okay, so that's the decision we'll work on later on in class. Just when you see a problem, how are you going to know which is which? For now, though, we'll just concentrate on this inside a quantity, get pretty good at this skill, and then we'll put things together tomorrow in class.